Good morning, students. So we have been discussing the problems of the condition of orthogonality of two circles. Third Roman we have started the previous class. Let us work out the fourth problem onwards. If the equation of two circles whose radii are a dash, or s is equals to 0 and s dash equals to 0, then show that the circles, this circle and this circle, intersect orthogonally. So if we try to solve this problem taking s equals to the general equation x square plus y square plus 2gx plus 2fy plus c equals to 0 and x square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0, then the problem will be more typical and cumbersome. So that is why let us take these two circles be in such a way that the line of centers lie on x-axis and the distance between the centers be 2p. Okay, 2a also we can take, but here a is already there, therefore 2p, and the radii are given a dash. So, and the midpoint of the x-axis is on, the midpoint of the x-axis is the origin. So, solution without loss of generality, let the line of centers as line of centers of the two circles as x-axis and the distance between them be 2p, and the midpoint as the origin. That means the circles are like this point. So since C comma C dash are the center of these two circles, and since this is 2p, that means this is p comma 0 and this is minus p comma 0. And the radius is a is given for the first circle, a dash is for the second circle. Circle is of the form x minus p whole square plus y minus 0 whole square is equals to r square. This is a square. So this is equals to x square plus y square minus 2px plus p square minus a square equals to 0. This is the first circle, and s dash is x minus of minus. So x plus p whole square plus y square is equals to a dash square. This implies x square plus y square plus 2px plus p square minus a dash square equals to 0. So, without loss of generality, let us take the two circles be in this way. So, so what do we need to do? Show that the circles, given circles are s by a plus s dash by a dash equals to 0, s by a minus s dash by a dash equals to 0. So, can I write plus or minus in a single equation, or s by a plus or minus s dash by a dash equals to 0. So circles, plural sense, that means if I take 1 plus, one equation of the circle we get, and if I take a minus, another equation of the circle I may get. So this is s a dash plus or minus s a dash plus or minus s dash a equals to 0. Therefore, the two circles are LCM. I find a dash if I transpose cross multiplication a dash into 0 is 0. So therefore the two circles are S a dash plus S dash a equals to 0 and S a dash minus S dash a equals to 0. So S a dash, consider S a dash plus S dash a equals to 0. That implies S is this circle, x square plus y square minus 2px plus p square minus a square into a dash plus S dash a. S dash is this, x square plus y square, x square plus y square plus 2px plus p square minus a dash square into a equals to 0. Now here x square plus y square into a dash, x square plus y square into a. So if I take x square plus y square as a common, then we are getting a plus a dash. Here minus 2px a dash plus 2px a. If I take minus 2px as a common, minus 2px a dash plus 2px a, take minus 2px as a common, then I will be getting here a dash. And here as minus has been taken common, 2px a minus taken common, therefore I am left with minus a. This plus becomes minus, and plus I am left with p square minus a square a dash, and so here p square a dash and p square a. So if I take here p square a dash, here p square a, p square if I take common, then this is a dash plus a, and this is minus a square a dash, this is minus a dash square a. If I take minus a dash as a common, minus a dash if I take common, here I am left with a here, and here a dash if I take common, I am left with a dash here. So since minus is taken common, this will become, this is equals to 0. So this is here minus a dash, I am left with a. So here minus, here what is this? Minus a dash square. So minus a dash if I take common, I am left with a dash. So this is what I get. So now x square plus y square into a dash plus a. Let us divide with to make this to be the general equation. X square quotient and y square quotient should be 1. For which let us divide this whole equation by a dash plus a. Then x square plus y square minus 2px a dash minus a by a dash plus a plus a dash plus a is common in both of them. So a dash plus a if I take common, so this is p square minus a dash. I have taken a dash plus a. So then if I divide, we are getting by a dash plus a equals to 0. So this into p square minus a dash. If I take common, here I am left with a dash plus a. So since I am dividing this whole equation by a dash plus a, that and this gets cancelled and I am left with is equals to 0. This is s a dash minus s dash a. So similarly s a dash minus plus s dash a is equals to, this is same, x square plus y square minus 2px. This is a dash plus a by a dash minus a plus p square plus a dash equals to 0. So question given is these two circles cut orthogonally. So we need to show that these two circles cut orthogonally. So to prove these two circles to cut orthogonally, we have to prove that 2gg dash plus 2ff dash is equals to c plus c dash. That implies 2g is how much? So this could be compared with the 2gx. So here g is p into, minus of course is there, minus p into a dash minus a by a dash plus a into g. G dash here is this minus, actually the formula is 2 is default in the formula itself. G is here, it can be compared with 2gx, then 2x same, then g is equals to how much? P into minus p into a dash by minus a by a dash plus a. So 2g, g dash is minus p into a dash plus a by a dash minus a plus 2ff dash. 2f, f here is, since there is no y coefficient, so this is 0. F is 0 here, f dash is 0 here also. So that is equals to, let us see what happens. So minus of minus is plus, a dash plus a gets cancelled, a dash minus a gets cancelled. So p into p is equals to p square. So this is our LHS. So RHS is equals to c plus c dash. So let us take c plus c dash. This is 2g, this LHS is what? 2gg dash plus 2ff dash is this. C plus c dash is, c is equals to how much? P square. This would be compared with the x square plus y square plus 2gx plus 2fy. Of course, f is 0 since we don't have y coefficient, plus c equals to 0. Here x square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0. Therefore, c is this, c dash is this. So p square minus a dash plus p square, here 2 is missing, 2p into p is 2p square. Now p square minus a dash, p square plus a dash, this is equals to this and this gets cancelled. P square plus p square is 2p square. Therefore LHS and RHS are same. Therefore the two given circles cut each other orthogonally. If the straight line 2x plus 3y equals to 1 intersects the circle x square plus y square equals to 4 at the points, that means circle is this. This is x square plus y square equals to 4 circle. and the straight line 2x plus 3y equals to 1. This is the straight line. This straight line 2x plus 3y equals to 1. This line intersects the circle. This is x square plus y square is equals to 4. If this straight line intersects this circle at the points A, comma B. So first of all, we have discussed whenever a line Lx plus My plus N equals to 0 and the circle x square plus y square equals to r square or x square plus y square plus 2gx plus 2fy plus c equals to 0, then the equation of the required circle passing through the point of intersection of a line and a circle is of the form s plus lambda L equals to 0, where s is the circle and L is the straight line. S plus lambda L equals to 0, where lambda is the parameter. So the equation of a circle, that means this is the circle. This is the circle. This is the circle. So this circle, this is the required circle equation. This is the required circle equation, and this required circle, find the equation of the circle having AB as a diameter. So diameter means the required circle, let us find now, and the diameter means the center of that circle lies, the center of this circle, required circle, lies on this line. So if we substitute the center in this line, then we will be getting the lambda value, and lambda value, if you substitute back in the equation that we are going to get after some time, then that is the equation of the circle. So the equation of a circle passing through the point of intersection of s x square plus y square equals to 4 and L 2x plus 3y minus 1 equals to 0 is s plus lambda L equals to 0. So s is x square plus y square minus 4 plus lambda into 2x plus 3y minus 1 equals to 0. That implies x square plus y square 2 lambda x plus 2 lambda x plus 3 lambda y minus 4 minus lambda is equals to 0. So this is also, is this not in a circle equation form? Of course, x square plus y square plus 2gx plus 2fy plus c equals to 0. What is this? This is the equation of this circle. This is the equation of this circle. Okay. What is this now? S plus lambda L equals to 0. Now, then find the equation having AB as a diameter. Now, first of all, what is the center of this? Minus G minus F. So, minus lambda, because 2gx plus 2fy plus c equals to 0. 2gx is equals to 2 lambda x. So, xx gets cancelled, 2 gets cancelled. Therefore, g is equals to lambda. So, the center is minus g, so minus lambda, minus f, so minus 3 lambda by 2. So what has been asked? Then find the equation of the circle having AB as a diameter. So for this circle, the line is a diameter. That means the center of this s plus lambda L equals to 0. That means this should lie on this straight line. Since AB as a diameter, the required circle's diameter, the required circle's diameter is 2x plus 3y equals to 1. So if this is a diameter is passing through the center of the circle. That means therefore C must lie on C. The center of this is equals to how much? C is equals to minus lambda minus 3 lambda by 2. C must lie on this line. 2x plus 3y equals to 1 implies 2 into x is minus lambda plus 3 into y is minus 3 lambda by 2 minus 1 equals to 0. This implies minus 2 lambda minus 3 3s are 9 lambda by 2 minus 1 equals to 0. That implies 2 into minus 2 minus 4 lambda LCM minus 9 lambda minus 2 ones are 2 equals to 0. That is equals to minus 13 lambda. Minus 13 lambda. Therefore, lambda is equals to minus 2 by 13. Substituting lambda in this equation. Let us suppose that this is s plus lambda L equals to 0, which is first equation. Lambda in 1. Then x square plus y square minus 4 plus lambda is minus 2 by 13 into 2x plus 3y minus 1 equals to 0. So this is equals to 13 into x square plus y square. 13 4s 52 minus 2 2s are 4x minus 2 3s are 6y minus into minus plus 2 1 are 2 by 13 is equals to 0. 13 when it is transposed to the RHS it will be 0. So this is equals to 13 x square plus y square minus 4x minus 6y minus 52 plus 2 is minus 50 equals to 0. If x plus y plus 3 equals to 0 is the equation of the chord AB of the circle. Circle is like this. So x plus y equals to 3 is the chord of AB. Let us suppose this is the chord. So the circle here is, this is s equals to 0. And for this circle, this line is x plus y equals to 3. This is the chord. So the circle and x plus y is equals to 3 is the chord. So let us suppose that the circle and the chord intersect at A and B. So we want a circle, equation of the circle having AB as a diameter. So the required circle's diameter is AB. So actually this circle. So this circle, clearly for this circle, AB is the diameter. So the same thing I have drawn here. Let the big circle here, this is s equals to 0 is the general equation of the circle, this circle. So the line x plus y equals to 3 is this. For this circle, this is x plus y equals to 3. Therefore, this AB is the chord of this S equals to 0. So, since the circle and line cut each other, therefore S plus lambda L equals to 0 is the equation of the circle passing through the point of intersection of a line and a circle. So now find the equation of the circle having AB as a diameter. So we want a circle whose diameter is AB. So this AB is the chord of the first circle, and now for this circle the same AB is the diameter. So let us try to do this. So the equation of the required circle passing through the point of intersection of S equals to 0, L equals to 0 is of the form S plus lambda L equals to 0. So before that, actually you can even write the given circle is this and the given line is this. Now S is x square plus y square minus 2x plus 4y minus 8 plus lambda into x plus y minus 3 equals to 0. That implies x square plus y square minus 2x plus lambda x. So minus x, if I take common, this is 2 minus lambda. This is minus x I have taken common, then this minus will become plus and this plus lambda x. X is taken common, then this is minus lambda plus 4y plus lambda y. Y if I take common, 4 plus lambda minus 8 minus 3 lambda. Minus 8 minus 3 lambda equals to 0. So otherwise if you take plus x here, plus x common, then this will be lambda minus 2. Then this is clearly of the form x square plus y square plus 2gx plus 2fy plus c equals to 0. So this is first equation. And what is this for this? This is the s plus lambda L equals to 0. This equation. So this is the general equation of the circle x square plus y square plus 2gx plus 2fy plus c equals to 0. So this circle is this circle in the diagram. Okay. So let us first try to write the center of this. Minus g minus f. So minus of lambda minus 2 by 2, comma, minus of 4 plus lambda by 2. Since I want the equation of a circle having AB as a diameter, since AB is the diameter of the required circle S plus lambda L equals to 0, the center of the circle S plus lambda L equals to 0 is also a circle. This circle. So AB is the chord of the first circle, but now same AB is the diameter of the second circle. Diameter means, so the center must lie on this line L equals to 0. So the center of S plus lambda L equals to 0 should lie on the line x plus y equals to 3, which is the chord of the first equation of the circle. So that implies x is equals to minus of lambda minus 2 by 2 plus y is minus of 4 plus lambda by 2 minus 3 equals to 0. If I take minus in common, this everything is plus only. So here lambda minus 2 plus 4 plus lambda plus 2 3s are 6 by 2 equals to 0. So lambda plus lambda is 2 lambda. So 6 plus 4, 10. 10 minus 2 is plus 8. This is minus 8 if I transpose. So lambda equals to minus 4. Simply substituting lambda equals to minus 4 in the equation number 1. Then x square plus y square. Lambda value is minus 4 minus 2. Minus 6 into x minus 6x. 4 plus lambda. So 4 minus 4 is 0 minus 8. 3 lambda is minus 3 into lambda value is minus 4. So minus into minus plus 4. 3 4s are 12 minus 8 is plus 4 equals to 0. So let us wind up this video by this last problem of the exercise 2a. So the problem goes like this. Find the equation of the circle. We want a circle equation. This circle is passing through the intersection of the circles. That means the two given circles are intersecting circles. So let the given circles be S dash x square plus y square minus 2ax equals to 0, s double dash x square plus y square minus 2by equals to 0. So here the intersection of the circles, since the given circles are intersecting each other, intersecting circles, otherwise intersecting each other. So for two intersecting circles, the line is a common chord. So these are the two circles that are given. So this is s dash equals to 0. This is s double dash equals to 0. Okay, then this line is a common chord. So this is supposed to be, for example, L equals to 0. Let L equals to 0 be the common chord of the given circles. L equals to s minus s dash equals to 0. That we have discussed before. So s minus s dash equals to 0. So x square plus y square minus 2ax minus of x square plus y square minus 2by. So plus x square minus x square gets cancelled, plus y square minus square gets cancelled. This is minus 2ax minus of minus plus 2by equals to 0. So if I take minus 2 as a common, then we are getting ax minus by equals to 0. This is our L. Okay, and find the equation of the circle passing through the intersection of the circles. So I want a circle which is passing through the intersection of these circles. So I want a circle. I have a circle of this kind. Okay. Find the equation of the circle passing through the intersection of these two circles. So let us suppose that AB are the points of intersection of these two circles. So there is the equation of the circle passing through the point of intersection of these two circles, that is A and B, this required circle. and having its center means, so the required circle's center lies on the line. So first of all, the equation of a circle passing through the point of intersection of two circles is given by s dash plus lambda l equals to 0 or s double dash plus lambda l equals to 0. Any one of this you may take. Okay, because this circle is passing to the point of intersection of s is equals to 0 and l equals to 0. Otherwise s double dash plus lambda l equals to 0. What is s dash here? S dash is x square plus y square minus 2ax plus lambda into the value of L is ax minus by equals to 0. This implies x square plus y square minus 2ax plus lambda ax. Take ax in common, then lambda minus 2 minus lambda by equals to 0. What is the center of this? C is equals to minus of lambda. C is equals to minus of a into lambda minus 2 by 2 comma lambda b by 2. So it could be compared with the 2gy, 2fy. 2fy is equals to minus lambda by. So y 2 get what is that? So this is equals to, so f is equals to minus lambda b by 2. So but center is minus g minus f. Minus of minus is plus lambda b by 2. So therefore c is equals to how much now? Therefore c is equals to, if I take minus in common here, a into 2 minus lambda by 2 comma lambda b by 2. So if I see the question and having its center means the required circle which is passing through the point of intersection of these two circles, that is this circle. So it's having its center means the required circle center, which is this, lies on this line. So if I substitute it, then the required circles center C lies on x by a minus y by b equals to 2. That implies whenever a point lies on a line, point has to satisfy the equation of a line. So in the place of x, a into 2 minus lambda by 2, this is x by a, so into a minus y means lambda b by 2 by b is into b is equals to 2. So here a gets cancelled, here b gets cancelled. So therefore 2 is the LCM for these two. Then this is 2 minus lambda by 2 is equals to 2. This implies 2 minus lambda, 2 minus 2 lambda is equals to 2 to the 4. So 2 minus 4 is equals to 2 lambda. So therefore 2 minus 4 is minus 2 is equals to 2 lambda. Therefore lambda is equals to minus 1. Substituting lambda is equals to minus 1 in equation number 1. So x in x square plus y square minus 2ax plus lambda into ax minus by equals to 0. This is what we got earlier. So substitute lambda equals to minus 1 in this. What is this? S plus lambda L equals to 0. We get x square plus y square minus 2ax. Lambda is minus. So minus 1 into ax minus by equals to 0. This implies x square plus y square minus 2ax minus ax is minus 3ax minus into minus. So 1 into by is plus by equals to 0.